Okay, what's an isotope? Well, an isotope is just an atom that has an unusual number of neutrons. Due to that unusual number of neutrons, sometimes this atom can become a little bit unstable. And what that means then is that it can change into a more stable atom, and when it does that, it releases radiation. We think of these atoms, sometimes, or these isotopes, they can be, they don't have to be, radioactive, which means they're going to release radiation. The radiation could be dangerous, it might not be dangerous, but they're in an unstable arrangement, or they're not in the normal situation where they have the normal number of protons and neutrons. A couple examples. Carbon-14. Carbon typically has an atomic number of 6, an atomic mass of 12, which means in a usual situation, the number of neutrons for carbon, the atomic mass minus the atomic number, would be 12 minus 6, or 6 neutrons. However, when carbon gets exposed to the sun and the radiation of the sun, it can turn into carbon-14. Carbon-14, what this 14 means is instead of having the normal atomic number of 12, now it has an atomic number of 14. With this, or not atomic number, sorry, atomic mass. So the normal atomic mass for carbon is 12. Carbon-14, the isotope, has the atomic mass 14. What this means then is instead of having its usual number of 6 neutrons, it's going to have 8 neutrons, meaning it has more neutrons than it typically has. This carbon-14 will eventually change into a different atom. It's unstable, but it's not very unstable. It takes a very long time for it to change. Usually it takes about 2,000 years for half of it to change from one type of carbon to another type of carbon. This is interesting because living things take in the carbon as carbon-14, and when they're dead, they don't take in any more carbon-14. So we can get an idea of when something died by looking at the amount of carbon-14 that still exists in its body. This is what we call carbon dating. Another example of an isotope, lithium-6. Lithium typically has the atomic number 6.9. So I don't know if you recall from a previous video, but that 6.9 was a little bit confusing. Oh, that didn't look any better. Hold on. Just erase that and write it again. This 6.9 was a little off-putting because we thought to ourselves, well, neutrons can't come in parts, so what does that 0.9 mean? Well, what that means is, and this is why it's closer to 7, is that most of the lithium is lithium-7. This is the normal atom, and we would say this is not an isotope. But it's not all 7. Some of it is lithium-6. You can do the math to figure out how much. It's about 10%. So this is the unusual atom, in that it only occurs about 10% of the time. That's not exactly right, but it's close enough. Anyways, this then has an unusual number of neutrons, and as a result, this is an isotope. Some isotopes are radioactive and produce really dangerous and lots of radiation. Some are radioactive, but produce so little radiation over such a long period of time that they're not really specifically dangerous. In the end, we call them all isotopes if they have an unusual number of neutrons. Say, for example, here, where this normal lithium atoms would have 4 neutrons, and these lithium-6 atoms, and that's how we say it. We say lithium-6 like that, only have 3 neutrons. That's what an isotope is. If I wanted to make the Bohr-Rutherford diagram, just quickly here for lithium-6, then to indicate that isotope, all I would do is have that unusual number of neutrons listed in the nucleus. So here I have 3 protons, my atomic number, 6 minus 3, 3 neutrons. So instead of having 4 neutrons in there, I have 3 neutrons, and then 2 electrons on the first shell. And assuming he's neutral, meaning my protons are equal to my electrons, then 3 electrons in the shells surrounding it, remembering our 2, 8, 8 rule. So that would be the Bohr-Rutherford diagram for the isotope lithium-6. This doesn't really have a huge effect on the chemical properties. If you look at the actual chemical properties of lithium-6, they're basically identical to lithium-7. So this can lead to that radiation we talked about, but from a chemical perspective isn't really an important difference about an atom.